Hello everyone, welcome to Power Electronics and Drives lecture series. In this session, we are going to discuss about the switching characteristics. Every power electronic device, that is, can be diode, transistor, MOSFET, or SCR, it not only abodes on and off, but also how fast and how effectively it switches between two states. This behavior will be calling it as switching characteristics, and it directly decides the speed, losses, and efficiency of modern converters, inverters, and drives. So in this video, we'll understand the switching characteristics in details for power electronic devices like power diodes, SCRs, etc. Power electronic devices, that is power diodes here, may look simple, but when they switch on and off in high frequency circuits, their behavior is far from ideal. The way they handle charge storage, recovery, and losses is what we call their switching characteristics. So here we'll discuss and why this is important. Here is it determines maximum frequency of operation, it acts efficiently, and it impacts heating and EMI circuits. So here first we'll go with switch on, then we'll go with switch off. So here switch on is T on. Okay, so this is your T on here. Here we have T on and T off as well. So first turn on characteristics. When forward bias is applied, a small delay before the current rises. That is because of minority carrier injection. Then current rises rapidly to the conduction value. And here the voltage drop is reduced to a small forward voltage drop, that is zero point 0.7 to 1.2 for silicon. The turn on is usually in variations of um, nanoseconds to microseconds. That is not a major limitation here. So here we have a time, right? So this is T1. Initially, it does not rises rapidly. It just goes beyond a small limit, right? It just increases slowly. At point after this point, it increases rapidly. So this is we are saying, okay. And next comes turn off characteristics. It's more critical than turn on. Okay, so when diode goes from forward conduction to reverse bias, stored charge carriers continue conduction for a short time, and it causes the reverse current to flow even through the diode. Should it should block that. So here we have storage time. The storage time is reverse current that stays high while stored charges is removed, and transition time is reverse current reduces zero. That is, we'll call it as reverse transition time. And reverse recovery time is the sum of storage time and the transition time. So normally, how you'll be saying the reverse recovery time is from the time taken from the conduction state to the non-conducting state. So that's the called reverse recovery time. So what are the factors that will affect reverse recovery here is junction temperature. So there will be some junction temperature already there. So it does not allow the device to switch off immediately. And next, doping level and device structure. Next, rate of fall of current. So these are the factors that will affect the reverse recovery of a diode. So next we'll just SCRs, switching characteristics of SCRs. So SCRs are the backbone of power control and rectifiers as know. And but did you know that the way they switch on and off is not instantaneous, right? So that's the thing. The time and the voltage, what is happening there, we'll be learning in switching characteristics. So here we'll explore the SCRs. So normally we'll have in switching on, we'll have three stages: delay time, rise time, and spread time. So delay time is time between gate pulse applied and starts to current rise. And here the charge carrier is injected near the gate, okay? And rise time, it increases rapidly from rapidly from 10% to 90% of its final value. So you can just look into here, your graph. Okay, it rises 10% to 90% of your final value. Okay, your current, it increases. And your voltage at the SCR, it falls. You can just look through it. Your voltage at the SCR falls here. And the spread timers, the current spreads uniformly across the junction and the device reaches full conduction. That's called as spread time. So the sum of all the three time, we'll be calling it as turn on time. So till this, we'll be calling it as turn on. Okay, turn on time, the time taken to turn on a device, SCR. Okay. So next comes the turn off. So how you'll turn off here is, and how the characteristics will be done here is, SCRs cannot be turned off by gate, but there must be current computation or any other computation techniques. When anode falls to zero, device does not regain blocking immediately. Charge carriers stored in the junction just recombine. So here we have reverse recovery time. The carriers in the outer junctions, it just recombines and the reverse current flows briefly. And the reverse in gate recovery time, the carriers in the inner junction recombine. So the SCR fully regains its blocking capacity and the device will be going to switch off. So here in it's used in low medium frequency rectifiers, general SCRs, and inverter stoppers require fast SCRs. So it depends. So the switching characteristics of an SCR, turn on delay, rise time, spread time, and turn off delays. It has reverse recovery time. So that's all with this session. Thank you.